Welcome, everybody. So hope your weekend was good. So we got a lot of cool stuff to talk about today. So first, though, we have to continue with what we didn't finish last time. I'm hoping to get fully caught up by end of this lecture, so we'll see how well we do. So if you remember, last time where we left off, we had this cross-origin communication using the post message API. And this was that nicer API that we introduced at the very end that allows two sites that want to cooperate with each other to send messages to each other. And one of the requirements of that was that the sites had to have, so one site had to have a reference to another site somehow. One way to do this, as you can see here, is to create an iframe and then load up the site that you want to talk to in that iframe. And then you'll have a reference to that frame, and then you'll be able to use the post message API to send it a message, right? And then the site that you're talking to can listen for those messages using the add event listener API. So a realistic example of this in action would be something like this. So say that you have access wanting to display the name of a logged in user, and it's going to find out that information from login.stanford.edu, which is on a different origin. Remember, the concept of origin is, what is it? Who wants to remind me? Origin is the tuple. What's in the tuple?
Protocol host import.
Exactly. Yeah. So obviously access.stanford.edu and login.stanford.edu are separate origins. So in order to do this communication, we're going to use post message. So here's how you might do that. So you might have access listen for a message, and it's expecting to be told the username in that message. And then it's going to embed an iframe to login.stanford.edu. And then the first thing that iframe is going to do is it's going to post a message to its parent. So the parent would be the window that included this iframe, right? So in this example, parent would be access, right? And so what's going to happen is that event is going to fire, and then we're going to be able to read this name object here. So this is insecure, though. So does anyone know why this might be insecure? Yeah? So somebody can mess with this name somehow. Interesting. Yeah, that's basically right. Yeah. So one way you could mess with this would be if let's say attacker.stanford.edu were to embed login.stanford.edu. Now, login.stanford.edu isn't checking anything about the parent. So it's just going to post a message to the page that included that frame and tell it the name of the currently logged in user, right? So in that situation, now some random other site that we don't want to know who's logged into this into access is going to be able to find out. This can be used for, like, let's say tracking or something like that, right? So any site on the internet now can literally just embed an iframe to login.stanford.edu and find out if you're logged into your Stanford account along with your full name, right? So do we see why this is a problem? Right, okay, so you could imagine maybe this page should check who it's sending this data to, so it's not sending it so indiscriminately. That would be one solution to this. Another sort of issue is potentially this page could be tricked. So access is including this frame to login.stanford.edu, and then it's assuming that a message is going to follow, and that message is going to include the name of the user. But this message actually could come from any page that has a reference to this window, right? This API literally just says a message was sent to me. It doesn't specify, at least the way that we've coded it up here, it doesn't specify where that message came from, right? So that's another issue. So let's go through maybe see a scenario about how this could be exploited. Actually, I have a question first. Yeah.
Would you mind just turning off the light?
Oh yeah, sure. There we go. So so we're going to represent origins by these boxes with white borders on them. So this is one origin here. We have access, and then access embeds an iframe to login.stanford.edu, and it waits for this page to post a message to the parent window. And this origin is going to listen for that message. So this is fine. This is the normal scenario. Now, this is where it can go wrong. So what if an attacker site embeds login.stanford.edu, as I said before, so this page is currently indiscriminately just sending a message to whoever the parent is. And this is how we sort of leaked the username now to any site that wants to find out. OK, so what about a just to review this, the way we solve this is we need to validate the destination of where we're sending our messages. And if we don't do that, then any attacker can just embed this page and find out who's logged in. So the way to do this is to just have the browser do it for you. So the API supports this additional parameter here, and you just say, this is the origin that I'm trying to talk to. And the browser will just not let this message go through if the parent is not matching this origin. So maybe you could try to be clever and sort of check it yourself by using the this variable here and maybe looking at the origin of it and checking the origin yourself. But you might make a mistake. So it's nice to just use the API and have it do that for you. Yeah.
But if you want to enable a bunch of different websites to be able to receive this message.
Yeah. So one thing you could do is you could try to like pull off the page that is on the parent and then use that origin in the string here. That's one way to do it. I think another way is you can pass an array here of multiple origins, but I'd have to double check that. But yeah, there is a way to do that. Cool. Any questions about this? Yeah.
So are you able to say, can an attacker website index some other Stanford.edu website at login.stanford.edu might trust, and then through that website embed login.stanford.edu? Is that a possibility?
That's a possibility, yeah. So this is just checking that to repeat the question, is it possible that some untrusted site, attacker.com, embeds some Stanford site that embeds login.stanford.edu? And login.stanford.edu happens to trust that particular Stanford site. So now it's going to reveal the name to this particular Stanford site, and then maybe this Stanford site hasn't done its security correctly, and now this sort of top-level page can attack this particular Stanford site, and that's totally possible, yeah.
So is there how would browsers / web pages usually prevent it?
I mean, so at this point, you've sort of told this site your name, and I think at that point, you're kind of trusting it to not do something irresponsible with it. In this situation, I can't think of a way that you'd solve that. I mean, if you're assuming that this site is completely incompetent, right? Then in the worst case, it could literally just take the name that the login.stanford.edu just told it, and then post it to a site somewhere, right? And there's nothing that the login page can do at that point because it's already given the information up. Yeah.
If you change the URL on the second parameter to just be stanford.edu, https://stanford.edu, can Access still listen to that message?
No. So that's a different origin, right? By our definition of origin, the host name is different, so it's different origin. Yeah. OK, cool. I'm going to move on. So this is another scenario. This is sort of the opposite scenario. So here we have an attacker, and the attacker is going to embed Access. And here we're assuming that Access doesn't do anything to prevent itself from being sort of embedded in a frame. And then now Access is going to include login. And remember, Access here is listening for messages, and it's expecting that the message it's going to get is going to contain the username, and that it's going to come from this particular frame here, right? Now, its mistake is it doesn't realize that it's embedded inside of an attack site. So what's going to happen is the attack site's going to send a message and say that, hey, this is your name, and login.stanford.edu might also send the message because it doesn't realize that that's already happened. And it may be the case that the Access site just trusts the first one it receives and ignores future ones or something like this. But you can see here that we're accepting messages from pretty much anyone who has a reference to our window, and this is a problem because it's really easy to sort of get a reference to a window, right? In particular, one really, really easy way is you can just open a pop-up window. Or in modern browsers, that'll actually just open up in a new tab. And if you do that, the opening site has a reference to that window now and can now sort of send it these messages. So this is a problem. Any questions? Does this make sense? OK, cool. So the way we fix this is we need to validate the source of our messages. And fortunately, this event object has a really useful property called origin. And we just need to check that against the origin that we're expecting to receive our messages from, and then we're all good. So one issue, though, with this API design is it's a little bit easier to forget to do this. Because with the other API, we had this sort of, it was like this is a parameter. So it's like, you actually can't, I believe you can't call this unless you pass a parameter here. So if you forget this, you're going to get an error. Well, whereas in this case here, it's easy to sort of forget to do this validation. Yeah, cool. So does this make sense? Cool. All right, so that's how we get sort of integrity from post message. The sender specifies the origin that they want to permit to receive the message. And oh yeah, this is sort of interesting. So it's also possible that the Windows sort of has changed in the meantime. So you might have, here's an example. Like say you have a page, and you embed login.stanford.edu, and then you're going to sort of send it a message. It's possible that some other script on the page has actually navigated that frame elsewhere in the meantime. You might not want your message to go to wherever that frame happens to be pointing right now, right? You probably have a bug in your site if random code is changing this frame, but we want to sort of ensure, even in that situation, that our message doesn't go to the wrong origin. So that's what we can do there. And then this is the flip side. So the recipient validates the identity of the sender, and this protects us against some other random window happening to send us a message. So yeah, just remember to always specify these things when you're using post message. Cool. So we talked about all these different sort of exceptions to the same origin policy. We mentioned document.domain. We talked about this fragment identifier communication, and then now we've talked about post message. And there are the thing to remember is there are these sort of automatic exceptions to the same origin policy that can bite us. So things like pages can embed images from other origins. Pages can submit forms to other origins, as we saw last time. And these can be the source of many, many security issues. So just a quick, I guess I already told you the answer. So which of these requests would be allowed? So what about the CSS file? Is this going to be allowed? Can we reference this? So if we're on example.com and we're embedding a CSS file from other1.com, is that going to be allowed? Who said, what was that? Go for it. You. Yeah, it's totally fine. Yeah, this is actually how you often you'll use Google Fonts. So you'll embed a CSS file with the fonts from Google, and they give you a CSS file to do that. So it's totally fine. What about the image? Yeah, the image is fine. And then the script, I think last time there was some uncertainty around whether you could do this with the script. Can you do it? You can, yeah, it's totally fine. So when this script loads, though, it's loading from other3.com. And so I have a question. So is this script running in the context of other3.com, or is it in the context of this page here? In the context of this page. This page. Yeah, that's right. Yeah. So it's as if we took the code here and we just literally pasted it into this page. That's all it's doing, right? So that's why that's allowed. There's nothing sort of, it's very unlikely that there's going to be some sort of private user information inside of this script. This is just code, and we're saying on this page here that we want to just execute that code in the context of our page, and that will be allowed. So
that's why, for example, if you're embedding like jQuery, that's why it works?
Yeah, exactly. Because you would, if you imagine you're running jQuery, it's doing all this stuff sort of to create this big API object for you. And if that just happened to be like, oh, that's over on the jQuery site, then what did that accomplish, right? It didn't really do much for you. Was there a question back there? Okay, cool. Cool, so basically, yeah, all of these are allowed. And then these are just some examples of this happening. People do this, and this was basically designed this way for. Well, I don't think it was designed. It was sort of just the browser added these features. This was allowed, and then at some point later, we got the same origin policy, and then these sort of things which involve different origins communicating with each other were sort of grandfathered in and allowed to function. Even though they sort of feel like they violate the same origin policy because we have different origins interacting with each other, even sort of without the permission of the other origin we're interacting with. Yeah.
This is just related to the tag and not like the MIME type of the file or anything.
Yeah, the MIME type, well.
Like anything with the script tag is allowable. Anything with an image tag, regardless of the file.
It's basically right. Yeah, there's a couple edge cases there, but I don't want to really get into it right now. Yeah, we can talk after class. Cool. So yeah, and just remember that these requests have the ambient authority that is given to them by the cookies that are going to be automatically attached by the browser to these requests. So in particular, here's a really sort of maybe an unexpected example. So if you're on attacker.com, you can embed an image from target.com. So say this is some social network. You can, if you happen to know that the social network will show, will make this URL show the avatar of the currently logged in user, then you can go ahead and include this in your attack site to make it seem like you know who the user is, which might make your page more convincing if you're trying to phish the user, right? So what's going to happen here is this request is going to have the cookies attached for target.com, and now this social network is going to get this request for this image. It's going to look and say, the cookie is for this user, okay, and return that user's avatar, and that will show up in this page, right? Yeah.
So is there anything stopping like a Google phishing page from like just literally like taking Google CSS and images and just using those?
The CSS of the images are totally, I mean, yeah, they can totally be directly referenced to the Google page. I mean, even if that wasn't possible, you could just save them and host them from your own page as well. So it's not really, yeah. In particular, so this thing here is maybe not that common. What you might see more often is this will be some sort of URL that's unique to the user, and so this isn't that much of an issue in practice, but it's something to be aware of. So is there a way to fix this? I think we talked about it last time. Who remembers the one way that target.com here could protect itself from attacker.com? Mm-hmm.
They use the same site name from the cookie, so that like you can't send the cookie if it's like requesting a, I don't know, what is that referred to as? Like what kind of resource is it?
It's a cross-origin request. Is that what you mean?
Yeah, but like there's like specific resources you can and can't request, right?
Yeah. So do you mean like the fact that this is an image will
like,
be allowed? Yeah.
is it like
Oh, a GET request.
or something?
Oh, yeah. So you're talking about, yeah. So does everybody remember same-site cookies from last time? So if target.com, when it logged the user in, if it attached the keyword same-site to that cookie, that would mean that the cookie for target.com now will only ever be attached when we're making this request from target.com, from a page on target.com. What's happening here is a page on attacker.com is making a request for this image. And so the cookies would not be attached. And so now we're going to get back whatever the server sends back when a non-logged in user requests this URL, which might be something like a sort of a generic avatar or something like that. And there were two modes on that same site. There was like lax and strict. You could look it up on the slides. But yeah, that's the approach to fix this. So yeah, to run through the exact sort of what requests are going to be made. So target.com, if it's making a request, then the browser is going to say, OK, yeah, we can attach the cookie. You're requesting avatar.png, and since you're on target.com and you're making a request to target.com, we'll go ahead and give the cookies. Whereas if you're making that request from attacker.com, you'll notice the cookies are omitted there. Mm-hmm. From an iframe? So do you mean like you've iframed target.com and then it made the request? Oh, then I think it would be allowed, yeah. Yeah, that's right. So in general, you don't want your site to be iframed because lots of things become possible when you allow that. And I'm going to talk about how to not allow that in this lecture a little bit later. But yeah, that's really important, yeah. Mm-hmm.
So when you say site is not iframed, does it mean like there's a way to not embed the site?
Yeah, there's a way for a site to say, like, I don't want anybody to put me in a frame. And we'll get to that in a sec. OK, cool. So yeah, so use same site, and then we solve this problem. So one other idea you might have is if you notice in these requests here, there was this referrer header, right? And the referrer header is the browser telling the server, this is the page that made the request for this image. It's also used when you click a link to indicate to the page to the server that you're talking to what the previous page was that you were on before. And remember, this is the misspelled header that we talked about in the very first class. So you might think, well, OK, I'm a server. I'm just going to like let the cookie be sent. I don't care. I don't need to use same-site cookies because I can just look at the referrer header. And if I'm target.com and I see that a referrer is coming from attacker, well, then I'll just not respond, right? That seems like it would work, right? There's a problem with that. In particular, for this case, because we're using an avatar image, it's common that these types of images are cached by the user's browser. And something really bad can happen if the image is already cached. So I'm going to run through that, and we'll see what could happen. So here we go. So let's say so this is the client. It's going to make a request to, this is target.com server. And we'll see here the cookie was attached, so excellent. And now the server is going to look at that and say, do I want to let this image load if it's being loaded from target.com? And since we want to allow that, it's going to be OK with that. And so it's going to respond with the image. So far, so good, right? But notice it cached the image. It told the browser, don't bother re-requesting this for a really long time because, I know it's not going to change. So now, if the attacker embeds that same image, and we're hoping that this request is going to make it to the server, so the server can do this check against that refer and make sure that it matches. But what's going to happen instead is it's going to just hit the browser's HTTP cache, and it's going to say, wait a minute. I was told that I already have a copy of this image. I put it in my cache. And so it's just going to return that right away. And so we have the same problem again. Does that make sense? Yeah?
Does the cache check if the request is the same and the cookie parameters are the same?
So it doesn't check, in general, doesn't check that the headers are all the same. Because in general, there's going to be a whole bunch of them that are different. Like the page that's the refer in particular is going to pretty much always be different because you're loading the image from a different page, but you still want it to use the cache if it can. But do you remember there was a solution we talked about last time for this? Or not last time. I think it was the first or the second class. There was a header you could use that would tell the browser cache, hey, when a particular header is different, then don't use the cached version. It was the very header. Do you remember that? Anyway, so that's one solution to this. But we already have a better solution. Just use same-site cookies, and then you won't have a problem. Yeah.
Do any browsers ever check the refer headers so that if it's a different origin, don't load the cached image or?
No. So I mean, if you think about the scenario we talked about, the idea of hosting jQuery or whatever JavaScript library on a central CDN server. So Google actually runs a server that just sort of hosts these really popular JavaScript libraries on their site. And all kinds of different sites on the internet embed that script. And so one of the reasons why people want to do that is because if you're including the same script that's included on a bunch of other pages, it's likely already in that user's cache. And so the kind of idea is oh yeah, they're on my site. It's a completely different site, so the refer is going to be different. But I still want to utilize the cache in that situation. If you didn't utilize the cache, then in that situation, then it kind of doesn't make sense to really have a CDN anymore. Does that make sense? Yeah. Cool. Cool. Okay. So yeah, basically the refer header kind of can kind of work. I don't recommend this approach is has some problems. If you tell the browser that you sort of the refer header really matters in terms of if it's caching, then it will sort of treat everything with a different refer as a different cache entry. But now you've kind of broken caching. You can also just sort of tell it to never cache the image, and then you are guaranteed that every time this request is made, it's going to hit the server because there's no cache anymore, right? So that would make this approach work. Cool. Oh yeah, and then there's one other huge problem. So there's a way now for a site to opt out of sending the refer header entirely, which defeats this whole sort of refer scheme. So it's funny how this was actually a browser feature that was added for privacy reasons. So here's an example. So why would a site want to why would a site want to not send the refer header to all of its sub-resources and to all of its sites that are clicked on, where links are clicked from a page? Can we think of a reason?
Then you can keep track of what sites your customers are visiting.
So that's actually really useful for site owners, though, because people who run sites want to know where their visitors came from. But yeah, so yeah, it's a pro and a con. But there's one situation where it's really bad to know that for the refer to sort of leak out. So what about a Google Doc? So if I click a link in a Google Doc and I go to some other page, and that page is allowed to see what page I was on before, what's the issue there? Yeah.
The doc is just unlisted but available to be viewed, and they could
Yeah, that's right. So oftentimes they use Google Docs use URLs as sort of a secret key, where only the person who knows the URL can access the document. And so in that situation, it would be really bad if every link I clicked is just sort of telling that site, hey, by the way, I came from this random private Google Doc where we're sort of talking about your site or whatever, right? So Google in that situation sort of say, we don't want to send the refer header to any links outgoing from this page. So that's a feature that really makes a lot of sense in this case. But it happens to sort of break this defense we were using up here. If that makes sense. Mm-hmm?
Yeah, I was just wondering if you'd heard of there was recently an Instagram problem where you could go and visit private Instagram posts if you had the link. Is that the kind of the same thing here? Like where it's a private link back to a post, even if the account is private.
Oh, so I see. So if you remember the link, you can get access to it?
Yeah, like even without logging in, essentially. Like, is that the kind of the same thing where you don't have to be logged into the Google account to see the person's private Google like forum or whatever?
It seems related. Yeah.
Okay.
Yeah.
I was just wondering if okay.
Yeah. Mm-hmm. Cool. So and then there was the other case where we have this sort of ability to send forms, and then the cookies get attached to the forms. That's the other sort of other ambient authority sort of situation here. So yeah, just to sort of review the interaction between the same origin and cookies. So the sort of conflict, the policies conflict in some sense because they were designed sort of at different times, and cookies sort of weirdly are more specific and less specific than the same origin policy, right? So they're more specific because they imply that you can scope a cookie down to a particular path on a site, and we know that is actually ineffective because we can always include a frame to sites that are on the same origin as us and read those cookies out. So this is sort of an ineffective mechanism. But yet at the same time, they're less specific than the same origin policy because of this sort of weird ability for attacker.stanford.edu to set cookies for stanford.edu, right? Whereas these are not the same origin. So anyway, the model here is very sort of different. So just keep that in mind. And by the way, one really sort of weird interaction here is if you remember the DNS hijacking we talked about before. So this was the idea that your internet service provider would notice that you visited an invalid domain name and then return you sort of a hijacked page with a bunch of ads in it because they know that that's not a real site, so you're not going to really miss out, and they figure they might as well make a buck off of that. And so if they do this though, and you remember how attacker.stanford.edu can mess with the cookies for stanford.edu. So if I go to let's say nonexistent.example.com, and my internet service provider notices that, so that's not a valid URL, and it gives me that ad page. Now the JavaScript running on that ad page can read all the cookies for example.com, which is really bad. Even if we assume that they have good intentions and they're not going to do that with this ad page that they're serving us, it could be that the page is insecure in some way, or there's a malicious ad included in the page, or something like that. And now, now we're in really big trouble. So in particular, it's possible. Let's say that the page is sort of insecure in a way where if we were to go to this URL here, nonexistent.example.com/some attack code, our DNS would be hijacked because the internet service provider would see that this is not a valid domain, so it would return us this ad page. But say that it sort of did something wrong with this code here, included it in the output of the page. So now this sort of attacker is now running this code in this page, and now this code can read the cookies for example.com and even set cookies for example.com and do stuff like that. Does that make sense? So yeah, the difference between those two sort of models is sort of the source of all kinds of issues.
Can you explain why non-existent.example.com can access cookies, even though it's a different origin?
Yeah. So this is just sort of the rules around cookies are just different than same origin policy. So in particular, it allows more specific, I don't know if you remember the rule from the other lecture, basically more specific names can mess with less specific names cookies.
Oh.
That's just sort of the way it works, because it was made before we had the same origin policy, and we haven't sort of went back and changed that. Yeah.
If example.com was using TLS, the non-existent.example.com would have to set up a TLS session to get those cookies?
Yeah. So
But not like a valid example.com certificate or anything.
I didn't understand the question.
Sorry. Okay, it would have to be HTTPS, but
Yeah, so
they could come up with their own certificate.
HTTPS fixes this. So they wouldn't be able to intercept non-existent.example.com if we sort of mandated HTTPS for our whole site. Yeah. Okay. So yeah, we have. Oh yeah. I'll just skip to the next lecture where we're going to introduce this. So here we go. So now we're going to talk about sort of ways to mess with the same origin policy and make it sort of more specific or less specific for different use cases that we might have. And then we're going to talk about an attack called cross-site script inclusion, which is pretty cool. Okay, so before we start this, I just want to motivate this with a question that I think is kind of cool. So I was looking in my Gmail, I opened up Gmail and I was looking in the web inspector and I was looking at the requests that Google was making and looking at the responses. And I noticed that like this was a response that I got back. So it hit some endpoint that Google was running, and it sent back this response. I removed a few things that looked like they might be like important ID numbers, so that's why I have redacted in there. But but basically the structure is basically the same. And you'll notice there's this really weird set of characters at the beginning, and I thought that was kind of fishy. Has anyone ever like bothered to like look in their web inspector and seen anything like this before? Yeah, so you probably don't like debug Gmail very often, but yeah. But yeah, it's really weird. So I was looking into what does that mean, and so I think hopefully by the end of this we'll all understand why they put those characters in there. Okay. It's probably for some important reason, right? They wouldn't just add it for no reason. It's probably defending against some kind of an attack. Okay. Okay, so now let's talk about sort of ways to configure the same origin policy. In particular, we might want to harden it in certain situations. We might want to relax it in other situations. So the defaults are these. This is what we talked about before. So we said a site can link to another site, a site can embed another site, but a site can't modify an embedded site. A site can submit forms to another site, and it can embed images and scripts from another site, but it can't read data from that site. This should all be familiar. Okay, so let's talk about how we can maybe harden this. So in particular, I notice sites are allowed to submit forms to me, and they can embed my images and scripts, and they can link to me, and they can embed me. Is there a way for me as a site to say, you know what, I don't want any of this stuff. Like I want to just firewall my site off from everybody else, so no one can do any of these things to my site. So we're going to talk about how to do that. So let's look at them sort of in order. So the first thing was, can we prevent a site from linking to us? This one seems like a tall order because linking is sort of very fundamental to the way the web works. But I sort of thought through, would there be a way to do this? Here's what I came up with. So well, first, why might we want to do this? So one reason is Google actually, and other search engines, they actually look at sites that link to you and use that to figure out the sort of reputation of your site. It's a little weird because anyone can link to you, and it's not really your fault if a sketchy site links to you. So if you Google around and you search, how do I prevent a site from linking to me, you'll find often it's people who are penalized by Google in some way, and they're like, how do I prevent all these sketchy sites from linking to me? Google thinks I'm sketchy because of that. And the sad sort of answer to them is you can't really prevent somebody else from making a link to you. You just can't. There were sort of other models for how the web might work that involved sort of two-way links with integrity, where this sort of site you're linking to had to sort of almost like agree, and it was sort of confirmation that link existed. But that's not the web that we have today, and so yeah, there's no answer for these people. But maybe there's a way to make it so that when somebody clicks a link to our site, we can sort of return an error page or something, or send them away, redirect them elsewhere, so they can't load our page up. Maybe someone's linking to us and smack talking us, and we want to sort of and they're linking to particular blog posts of ours, and we want to sort of just make those look like they're 404s when the person comes from that link, right? I don't know. Just trying to think of why one might want to do this. So how might we accomplish this? So yeah, we can't actually prevent the link itself, but we might be able to reject the request when we get it. So does anyone have ideas? The refer, yeah, exactly. It's just what we mentioned before. Look at the refer. So this is what the request to load our homepage is going to look like. And if we see maybe, a competitor wrote a blog post about us, we want to sort of give them a different page. We can do that, right? The thing we have to watch out for is that header I mentioned before, though, where the competitor can specify that they don't want the refer to actually get sent. This was very useful for the Google Docs case, but in this case, it would foil our plans. So in particular, there's a few different values you can set for refer policy. The default used to be this. It used to be unsafe URL, which is it just sort of sends the full URL of the page that had the link in it to the site that was linked to. But now we actually have a different default, which is this one, which is in particular, it's basically the same. The difference is if you have a secure site linking to an insecure site, we don't want, so the insecure request here, this HTTP request, is going to be visible to everybody sort of on the same network, right? So that everybody in the same Starbucks as you can see that request. Your ISP can see that request. The NSA can see that request. And so in particular, we don't want to reveal the particular page you were on the HTTPS site. We don't want to tell the HTTP server, hey, we were on this page over here, and because now we're not only telling this site, we're telling sort of everybody on the network that particular information. So when that downgrade happens, we just don't send a referrer, and that's the new default. But there's these other options. You could say, just never send it. I don't care. I don't want it to go out. You might say, what, I don't care if the site knows that, So maybe our competitor wants us to know that they linked to us, but they don't want to let us know the particular blog post that the person was reading when they clicked the link. And so they could just send us their origin to let us know, that they're talking about us somewhere, but we just don't know what page of their website they're talking about us on. Do these values kind of make sense? Yeah.
So these refer policies are something that the site coming from is specifying. Like if I'm going from example.com to other.com, like example.com is the one specifying these refer policies.
That's right, yeah. So this policy is specified by the site that has the links in it. And when the links are clicked, this policy is what takes effect and affects the requests that are generated by the clicks on the links. That affects the refer header in those requests from the links. So the way to think about this is Google Docs would set this policy to probably to this. I should have looked at what they actually set it to if somebody wants to inspect Google Docs and see what their refer policy is. But basically, when you would go to load the Google Docs page, they would send you back this header. And now, anytime you click on a link from Google Docs, those links, the servers that are at the end of those links, are just going to get the origin. They're going to know somebody from Google Docs some Google Doc linked to us, but they're not going to know the particular doc that did it, right? Because it's not going to contain the path. Does that make sense? Yeah.
Why not just I don't know, specify the refer yourself,
Oh, just set it something random?
Yeah,
Well, if the user is clicking a link,
because you're the one sending the request.
So when the user clicks a link, the browser, the URL bar sort of changes to the destination of that link, and it's the browser that's sending that request.
Yeah.
So the site that contained the link needs to tell the browser, hey, when you actually send that request, when the user clicks on a link, make sure to set the refer as I specify, as the Google Docs site specifies.
Oh, okay. Otherwise,
It'll just include it helpfully. Yeah. Yeah.
And when we use downgrade here, we just mean that the protocol in the link tag is HTTP and we're on HTTPS site, not a TLS downgrade.
No. It's much simpler than that. Yeah, it's just a secure site linked to an insecure site. Yeah. Okay. And there's a few other values which are get even more sort of complicated. Let's see, what's worth mentioning here? These are just, so the reason why these ones exist is because if you notice here, say that I don't want to leak the sort of full URL. So I have a site and I don't want to, here's an example, Google Docs, again. So Google Docs doesn't want to leak the full path to a doc, and so they use this header. But now if the user clicks on any links that are from Google Docs to Google Docs, let's say they click the privacy policy link, or they click some other link to another page of Google Docs. Now, even Google itself now is not getting the refer header. So they can't learn sort of how users are flowing through their site. And so there's options where you can say, you know what, let's see, send the full URL when we're on the same origin, but send nothing to other origins, and things like that. There's sort of these different trade-offs you can make. OK. This isn't that important. You can look at it if you ever need to use it. So yeah, anyway, to summarize, it seems pretty hard to prevent linking. Let me know if you figure out how to do it. But the best you can do is sort of look at the referrer and try to be naughty and do different things when you see a different referrer. But you really can't rely on that. This one you think they're going to use? Oh, that is what they use. OK, so what is that one doing? Let's see. So they're saying that they want the full URL, obviously, so they can track how you're using Google Docs. And then they want cross-origin sites to see just that you came from Google Docs. That makes sense. So they want to get credit for sending you that traffic, but they don't want the site to learn what the private doc URL. And then lastly, they want to send nothing when you're downgrading, when you're clicking an insecure link from a Google Doc. Kind of makes sense. Yeah. Cool. Thanks for looking that up. Yeah, that makes sense. But that's quite a mouthful for a policy. OK, so now let's think, is there a way to prevent embedding our site? So all kinds of really nasty attacks can happen if someone can embed your site. In particular, we mentioned clickjacking attacks. So that's one kind of attack. I don't think I've actually shown. No, I did show the one that I found when I was a student in this class. But to remind you all, this is clickjacking. So we're on a sort of attacker site here, and what's going on here is this attack site, example.com, in this situation is embedding an iframe to eBay, and it's allowed to sort of shift this frame around however it wants using CSS, right? And so it's decided to shift it off the page a little bit. But it knows the layout of eBay, and it knows the sort of size of the box that it's selected. So it can predict exactly where this bid button is going to be, or I guess it says buy now. So it can predict exactly where the buy now button is, and then it can make sure to put its own button right in the same position. And but in particular, what's going on here is the frame here, this sort of transparent or translucent frame, is actually on top of this button. But its opacity is going to be set to 0. So it's going to be invisible, but it's actually on top. And so the user is going to see the green button, but when they click, they're actually going to be clicking the blue Buy Now button on eBay. Does that make sense? So yeah, this is one type of attack you can do with clickjacking. It's pretty bad.
So when the user clicks, the one on top is the frame, right?
Yeah.
So the frame registers the click first.
Yeah. You can imagine if this frame was set to sort of be fully visible, then what the user would see would be just this chunk of the eBay site, and they wouldn't see the green button at all, right? So it's on top.
Okay, and then how does that click gets registered back to eBay?
Well, I mean, the user is literally clicking in the frame. So, I mean, they're literally just clicking on the button on eBay. But the weird thing is that they see what they actually see is they see the attacker's site. Does that make sense?
So what I didn't understand is when a user clicks, since the attacker's window is in front.
No, the attacker's window is not in front.
Okay.
Yeah. So the pictures kind of it makes it look like this browser window is like the one that's on top. But yeah, no. Actually, the way they should have drawn it is this eBay site is actually on top. Yeah, this is actually, now that I'm looking at it, it does look kind of misleading. Yeah, so if you were to look at the sort of layering here, the eBay site's on top, then the button is behind.
Okay, and then how do you see the button?
How do we see the green button, the one that's behind? Well, we make the iframe sort of transparent with a CSS property. So you can make items, you can adjust sort of how opaque they are. And by default, everything is sort of fully opaque. So it's sort of, you see it right away. But you can make the opacity of it 0. And then it's invisible, but it's actually still there. Okay, yeah. I could just I don't have a demo of it, but I could just show you really quickly after class in my browser. Does that make sense to everybody? If it doesn't, ask more questions. Yeah.
So this would only work if, or I guess this attack would only be successful if the user or the victim is already logged into eBay and has your credit card information stored.
Yes, yes, yeah. So they have to sort of all be in the perfect state for us to sort of get, like, what's going to happen is whatever would have happened if they had clicked that button normally. So if they weren't logged in, then yeah, they're just going to get the login form popping up or whatever. Yeah. Mm-hmm.
Would this only work over HTTP?
No, so this would work fine over HTTPS, yeah. So the main issue here is that this site is sort of allowing itself to get framed. It's not that, you know, if this site was secure, you know, and this site was secure, the same thing would work. It'd be exactly the same, yeah. But there is one thing that would prevent this. The same site cookies, again, would prevent this, right? Because if we use same site cookies, then this request to eBay would be sent without the cookies, and we would be sort of logged out of eBay. And that click wouldn't really do anything. Yeah, so same site cookies are really, really useful. Hmm?
If somebody needed to click twice, like there's a confirm payment button on the next thing, does the attacker actually get, like, does the click event just disappear into the eBay frame?
So
they don't actually, their site doesn't actually know that the user has clicked?
That's a good question. So the question was, so when the user actually does this click, since I said that the eBay frame is actually the one that's on top, that click is going to the eBay site, right? So our button that's behind doesn't actually get clicked on. So is there some way for this page, the attacker page, to know that the attack was successful? Because like as far as they can tell, like there's this eBay frame and the user, actually there's no way for them to know the user did something in the frame as far as I'm aware. I tried to figure out how to do that for a while when I was doing this, and I couldn't figure it out.
Do you have the URL of the frame? Like if it navigates, I guess?
That's a good question.
Which might not do, but.
Do you have the URL? I know you can change the URL of the frame. I don't believe you can read the URL of the frame. Yeah.
That would just be like a DOM attribute, though.
We can test it. Yeah, I think you can't actually read the URL because that would reveal. We should test it. Yeah, we should test it. Yeah.
But wouldn't you still send cookies with the eBay request because you're in a separate iframe, so you're on eBay lane?
Oh, are you saying if we use same site cookies, wouldn't?
It's still, if like the policy is lax, then it's
So
still.
if you say same site equals lax on the cookies, then I believe that this frame is going to be treated as a sub-resource request because we're not actually at the top level in the URL bar. We're not on eBay. We're on this other site. And so like the policy of same site is going to say which site actually sent us this request for this frame, and it's going to be this site, not eBay that did it. Yeah. Mm-hmm.
I just looked it up. You can only read the URL if it's from the same domain.
Yeah, okay. That's what I thought. Is it domain or it should be origin? Same origin. Okay, they just said domain. Okay. Yeah. Yeah, okay. Cool. So this is a really fun attack. Like if a site allows itself to be framed, then you can just do all kinds of things. Oh yeah, there was a lot of stuff going around with Facebook like buttons where people would make like clickbait sites that say, click here to see this crazy video. And then what they did was, they had like the play button. They would hover a like button directly over the play button. So, and this was at a time when liking something on Facebook would create like a newsfeed entry saying, Frost liked whatever viral video. And then everybody would click that to go see what it was, and then they would try to click the video, and it was sort of like a virus that just spread across all of Facebook. Yeah, and the other thing you can do too is you can actually control the zoom of the frame. Like you can transform it so that it's really, really big, and so you can make you can sort of take the like button and zoom it so that it's the entire page. So no matter where they click, they're just going to click this button for sure. Yeah. Yeah. Okay, let's move on. So yeah, so can we prevent this? And we would want to do this to prevent clickjacking attacks. So one way that was really common to prevent this was this thing called frame busting. But really what we want to do is a new HTTP header. So frame busting is literally just code where the site that's being framed looks at its parent variable and looks at it and just sort of tries to tell if it's being put in a frame right now. And then it sort of like tries to react to that in some way. And there was this excellent paper that some Stanford folks wrote a few years ago, maybe 10 years ago now, where they analyzed the techniques that sites were using to detect that they were in a frame and to bust out of it, and they found that literally every single version that anyone had tried was completely broken. They were able to break 100% of frame busting code. The idea was it would work something like this. So a site would say, so there's this variable called top, and top just tells you it's a reference to the top level frame. So it's like if you have a frame and a frame and a frame, then top just tells you the sort of top frame, the one that's the URL that the user is actually on in their browser. And it would look at that and say, is that location different than the location of my page, so my frame? And if it was different, then it would know immediately, okay, I'm being framed. I'm in a frame. And then it would try to sort of redirect the whole browser to itself. So it sort of would bust out of the frame and make it, so it might be this little box nested really deeply, but it sort of sets the whole browser to itself. That's the idea. But there were really a ton of ways to work around this. So in particular, I'll just tell you one really quickly. It's not that important how to do it, but because we have better techniques now. But what you could do is, if you're the top level site, you can detect that you're being navigated, and you have a chance to sort of react with JavaScript. Like if you're a page, you can say when I'm about to be unloaded. In other words, the user is about to go to an URL. Run this function, and in that function, you could basically you could interfere with this, sort of set yourself back to the original URL and stuff like that. And they found all kinds of ways to break it. It's a really fun paper if you want to go and read it. So it's called busting, frame busting. But anyway, so we have a much better way to do this now. You just add this single header here, and then all your problems are solved. So basically, what you can say is you say deny being framed, and then now this page can't be in a frame anymore. And there's sort of a middle ground here. You can say I want to allow myself to be framed by other pages on my own origin. And you can use that value for that. And so one thing I want to so I want to just sort of show the idea here. So here we have attacker.com, and it's going to embed target.com. And in this case, the target has specified that they only want to be framed by their own origin. Okay, so this shouldn't be allowed, right? So what the browser does is it looks at the header that was on the response from this request and sees that the site requested to not be included in a frame, and so the browser just denies. It doesn't load anything in that frame. It'll just be an empty frame, right? But what I want to emphasize here is sort of the order that this happens in. So let me show the HTTP requests that are going on here. So here we have the attacker server. So remember, first we load the attacker site, and then the attacker is including a frame to target.com. So we start off by sending a request to the attacker, and this attacker site loads in our browser, and then the attacker is going to send a request now. It's going to iframe the target. So a request gets sent to the target, and now this is where the defense happens. So the server, in this situation, it doesn't even know necessarily where this request is coming from. Like I didn't put the referrer header in here. We're not using that. The server is just going to say sort of blanket, I never want to be framed. So the way it does that is in the response that it sends, it says, only allow my same origin to put me in a frame. And it just always includes that in its responses. But you'll notice here, the attack page was able to send this request to the target server. It wasn't blocked. And we actually sent back a response with our like button or whatever inside. And we're relying on the browser to read this header and to do the right thing. So that the browser is going to analyze this here, and it's going to say, should this be allowed? And in this case, it's going to say no, because this would appear in a frame inside of attacker.com, so no. Okay, and then that response gets discarded. Does that make sense? Yeah.
So is it risky to rely on the browser against it? Because can't whoever made attacker.com also have their own scrappy browser that
I see.
to ignore that?
So yeah, with all these attacks, the thing we're trying to protect against is a legitimate user who's using a legitimate non-hacked browser, who is logged into in the example I gave before, they're logged into Facebook, and now they're going to attacker.com, and we want that browser to ensure that that the like button can't be clickjacked and cause them to send invalid requests to Facebook. So in your example, this attacker would be running their own hacked browser, and they would be able to clickjack themselves. Like they would be able to log into their own Facebook account, go to their own attack site, and then when they click the button, they're going to just post to their own Facebook wall, which they could have done anyways, right?
So you need to like hand a good person
A bad browser.
a bad browser.
Yeah, exactly. Yeah, and in general, like we can't remember. I don't think I mentioned this before. You know, we can't trust the client at all here. So I mean, this client, you know, this is like what you suggested is this could be like a hacked browser. This could be more than a hacked browser. This could be literally any script that anybody writes, right? So yeah, our server has to be safe against sort of anything here. But yeah, all the things we're talking about here are sort of trying to defend against state that's in the client, that is state for like sort of other pages that we don't want to get accessed by other origins. If that makes sense. Okay, cool. Okay, so yeah, so hopefully this makes sense. We're relying on sort of the browser to do the defense here. And so actually, when it comes to these kinds of defenses, you have to think about like how many browsers are what's the market share of browsers that actually support this feature? Because the users who are running really old browsers, their browser might not know what to do with this header. And so they're going to be vulnerable to this attack. And so you might need to sort of you might need to try the frame busting thing that doesn't work and throw that in there anyway. In the case of this header, though, this has been around for a really long time, and it's very pervasive. So you can just trust, pretty much, you can just trust that this will work. But in general, when you're looking at these kinds of defenses, it's important to think about what the sort of number of browsers out there that actually support it is. Okay, cool. So this is this is a really fun thing. So what does it actually mean when you say that I want it to be same origin? You know, I've been saying same origin here, and we've just been assuming like it's obvious that it means, you know, like in this situation, clearly this iframe is not being included by a site that's the same origin, right? But there's like another scenario we could come up with where it might be a little less clear. Let me just show you guys. So what if target.com embeds othersite.com, which embeds target.com? So now, is target.com being embedded by the same origin or not? So until recently, browsers considered this to be fine. They would just look at the here we go. What's going on here is this frame is saying I don't want to be framed except by myself, and this other site doesn't have an opinion. It's cool with whatever, and so the browser just what it would do is it would just check, you know, this against this and say, yeah, you're being framed by your own origin. So in particular, yeah, exactly. Yeah, I think that's it. Yeah. Does that make sense? Okay, so this was like really quite recent that this was allowed. So you could basically, an attacker could make it a framing chain that like worked like this. So the target would embed attacker, which would embed target. Now you might think like, how would this ever happen? Like, why would a good guy embed an attacker's site, which would embed the good guy? Can anyone think of where that might actually happen legitimately? Yeah.
Like a MySpace profile, something where you have like arbitrary HTML.
Yeah, so that's a good one. Another example might be, like a MySpace profile. Let's go with that. So this is your MySpace. What did you use MySpace? Just realized we're talking about MySpace. So this is MySpace, and then MySpace is including an ad. So this, the ad can be, it's going to come from anywhere. So it's very easy for this to be untrusted. And then now that ad is going to say, you know what? We know that MySpace allows itself to be embedded by itself. So we will embed MySpace. And so now your little box with your ad is actually going to contain another copy of MySpace inside that box. And now when you click on the ad, you might be doing some profile action, right? The clickjacking stuff becomes possible again. So they can hide some button there, and then they can make the ad look like something really enticing. And then when you click on it, you're doing some action on the site. Does that make sense? Yeah.
So this assumes that like target.com, or the attacker can somehow get their frame into like the topmost target.com.
Yeah. The target.com has to be the topmost. Yeah. Yeah, which is, in the case of the MySpace example, is not that hard because you're looking at someone's profile, and then there's an ad in there that's attacker, and it's like it's like not that hard to do. Yeah, so I have a sort of pictorial representation of it just to emphasize, so we can make sure we all see. So basically, yeah, here's our social network site. it includes this attacker site, which includes the social network site again. And the browser would say, are we on the same origin here? And it would do that comparison, and it would obviously pass because those are the same, and no problems here. But what we really want to happen is this. We want to make sure the entire chain is same origin. And so as of like, I don't know, a little while ago, Chrome and Firefox, I don't know about the other browsers, but Chrome and Firefox check this correctly now. So we can rely on this to actually work. It'll when it sees that one of those is not the same origin, then the whole frame is blocked. Cool. But yeah, these things are surprisingly subtle. The attackers just have infinite time to sit around and think of these kinds of things. So they just have to find one thing, yeah. Anyway, cool. Any questions on this? Yeah.
How does the browser check the whole chain again?
Well, the browser is the thing that's loading all this stuff. So it sort of knows like exactly what frames it's putting where. So it's pretty easy for the browser to just to check just check the origins of all the frames that it's loading. Yeah, and it'll only do that if it sees that something that's being framed has requested some particular policy. Yeah. Okay, so now let's talk about, is there a way to prevent a form from being submitted to our site? Because remember, we're trying to lock down our site. We don't want anybody to talk to us. We want to be super secure. So how do we prevent this? Well, first of all, why would we want to do this? So I mean, as we saw before, cross-site request forgery was pretty bad. That was the thing we saw where we were doing a transfer into someone's bank account. And we have a really easy way to do this we talked about, which is the same-site cookie. That prevents, well, sorry, let me step back. Same-site cookies prevent the cookie from being attached to one of these form submissions. But they don't prevent the form submission. The form submission will still happen. So what I want to ask here is there some way to sort of say, I don't want any form requests to come to my site. Cookies or no cookies. Just no one submit forms to me except myself. Like, I want my own site to be the only thing that submits forms. I mean, we can't really rely on that because of what I said before about how a client can sort of send anything they want. I mean, they can write a Python script or something that will send whatever they want. So this is kind of a fool's errand. This is a kind of silly question. But say we wanted to try. You have a question? Yeah.
No.
OK. So say we wanted to try. So one thing we could do is anytime the browser makes requests to other origins, it's going to add this origin header. And we could have a sort of an allow list on our server of origins that we will allow to do this. And we could check against it. That's one approach. The other approach is to use same-site cookies. But like I said, they don't actually prevent a form submission. They just remove the cookies. Yeah. OK, so does that make sense to everybody? OK, cool. So what if we want to prevent embedding images? So maybe our images are quite big, and say we have what's a 90, since you're using MySpace, can we think of other like 90s or 2000s examples? Say you're on some one of those Flash animation sites or something, or those Neopets, yeah. And so some other Neopets, so somebody made a Neopets competitor, and they are stealing all of our bandwidth because they, instead of making their own pets, they're using all the pet pictures on our official Neopets site. And so the Neopets company now wants to prevent those images that are being embedded from loading. So that's called hot linking, when another site links to your images and steals all your bandwidth. Because now you're paying for all those requests. So yeah, and then another case where we might want to do this is that example from before, where we were showing a logged-in avatar from one site on another site. So one thing we can do is look at the refer header and try to respond to that, like I mentioned before. But this is not foolproof because that can be manipulated by the attacker. And then same-site cookies was the thing that solved the avatar situation. So that would just that wouldn't prevent the request, but it would show the sort of the logged out image instead. Yeah. But yeah, basically the answer here is like you can try to sort of do something clever by looking at this header, but you can't rely on it. That's the answer. Another option for the avatar situation would be to sort of use an unguessable URL or something unpredictable. Yeah.
So is the origin header only used with like forms?
Yeah. So I realize that's a little confusing. Yeah. So I mentioned use origin before. So there's the rules when this gets sent are a little bit more complicated than what I said. This header gets added when the request is considered a CORS request. GET requests are never CORS because GET requests are always allowed. Images, scripts, styles. So this header actually doesn't get sent when you're loading an image from an image tag. But it will get sent in this case because it's a form is a post. Yeah. So.
And do we have the refer tag here?
We do have the refer here as well. Yeah.
Okay.
So we could use that as well. Yeah. I should have simplified it and just used refer everywhere. Yeah. You're right. You're right. Okay. Now what about scripts? So why would we want to do this? Again, same thing. Bandwidth. Maybe maybe we have a really cool sparkle effect on our website with a bit of JavaScript that we wrote. Have you ever seen those sites with the sort of the snowflakes that trail your mouse or anything like that? You looked at, yeah. So maybe we spent a lot of time writing a really cool effect, and now some other site included our script, and so the snowflakes are showing up on their site, and that's not cool. So we want to block that. Note the script in this situation doesn't contain any private data. It's just a static file. It's similar to an image or a CSS file. So we're not trying to block it because of that reason. We're not worried about anything like that. And again, also, we're not worried about the script like running on our site because when they embed our little mouse trail effect thing, it's going to run in their page. So again, we're not worried about the script running on our site. Really, what we're trying to do is just sort of prevent the bandwidth, the hot linking. So this is like one way where you might see this in like the real world. So this is using the Google CDN to load the D3 library. And so it gets loaded, and then right after that, we use it to do some D3 stuff. This is just a graphics library. So anyway, so that's the way we might use it. So can we actually prevent this? Again, it's the refer header approach. We can try to do that, but it's not gonna be that reliable. Okay. So yeah, so if we review our set of things that we wanted to, ways we wanted to change the same origin policy. So is a site allowed to link to another site? Yes, we can try to mess with it, but not really. It's not foolproof. Can site A embed site B? By default, yes. If site B doesn't want to be embedded, then no, and that works reliably. So you can do this on all your sites. Prevent your site from being embedded by another site. Solve a whole class of attacks. Very good to do. Okay. Can site A embed site B and modify its contents? Well, we've been talking about ways to strengthen the same origin policy, and this is already quite a strong policy, so that's still no. And actually, there's no way to relax this either. So a site that embeds another site can't reach into its DOM and modify it. So can a site submit a form to us? You can prevent that with by looking at the origin header, and that works quite reliably. If you want some middle ground here where you want to say, I want forms to be submitted to me, that's fine, but I don't want the cookies to get attached, then you can use same-site cookies. And then with images and scripts, we have this, again, this is basically allowed by default. You can try to mess with it, but it's not going to be foolproof. So you can try to strengthen that, but it's not really going to work. And then lastly, can site A read data from site B? And we said the answer was no here, but now we're going to talk about ways where you might want to allow this. But yeah, you can see here, you can turn some of these into no's, and then there's no way to turn this one to a yes. This you might want to turn into a yes if you're trying to collaborate intentionally with another site. So we're going to talk about that now. But before we move on, any questions about this? Yeah?
Is there no way for a site to prevent sending the origin header in case?
Yeah. So a site that's making a request to another origin can't manipulate the origin header. The browser ensures because that's used to make security decisions by the site that's receiving that request. The browser will set the origin header based on whichever origin initiated that. You can trust that the user won't be able to, the attack site won't be able to manipulate that in any way. Yeah. Okay, cool. So let's talk about how to relax the policy. So this is that last point there. So can site A read data from site B? And we said no. And remember, the reason why was because we were worried about this. This is the thing we don't want, that the browser doesn't want to allow to happen. So for example, you can't be on my site, my blog, and and you might be logged into Access in another tab. We don't want to allow my blog to make a request to Access for your transcript and pull that out as an array, basically, and read the data that's in that PDF, right? This would be bad. Yeah, so note that, so what's going on here is that this is like me getting the data in a variable, so I can literally like read it in detail. This is different than, say that this was actually like a GIF or something. Your transcript was a GIF. My site could put that into an image, and that would show up, assuming that the site didn't take other measures to prevent that. Does that make sense? So it's fine to include data in your page, but to actually read the bytes out of it is a different thing. That's a much more intense thing. All right? Does that make sense? Sort of a separate category of things. So that's what we mean when we say read data. We mean literally read the bytes of a response. OK. Cool. So this is what's not allowed. But say we want to allow something like this. In particular, here's a use case. So what if, well, OK, so actually, there is a way to do this that we talked about. We can post message, right? So I can embed an iframe of a page that's cooperating with me, and I can post message to it. And then it can post message back to me, and we can communicate that way. But what if I want to read data that isn't being generated by this page, but rather it's sort of an arbitrary response from a server? Like in particular, say that there's an API server. This is similar to what you did in the assignment 0, where that server just returns a JSON object with some information that I'm interested in. And I would like to make a request to that URL and get back this JSON object and do something with it. It wouldn't be possible to use post message to do that. Does that make sense? Because there's no page here that we can be sort of post messaging to that's responding to us and giving us the date or something like that. There's no HTML response here. This is just a JSON object, right? Any questions? Do people not? If you don't understand that, ask a question, please. OK, so basically, this could be our server code, something like this. We have an endpoint API, /API/date, and we're just going to send back this JSON object. This is what it looks like. Not too magical. And so now we want to enable this. We want site A to be able to, this date API is hosted on site B. So site A wants to make a fetch request to site B. This basically sends a HTTP GET request. And we want to read the data out and just console log it. So by default, that would be denied because they're different origins. We need some way for site B to say, really, this is OK. I don't mind. So you might think we could just maybe add an HTTP header to this, like we did before. And that is actually how it's often done. But I want us to think if there's a way to do it without HTTP headers first. Yeah?
Is this like where API keys come in?
No, it's sort of a more fundamental problem. Like, in this case, there's not even an API key involved at all. Like, the data's there. If you visited this URL in your browser, you would see this time get shown to you, right? So the issue is site A can't initiate that request and get the data out. We actually want to sort of open it up, not lock it down with an API key. Yeah?
Every server, can't you just launch an instance of Google Chrome, go to that site, inspect, copy HTML, paste it, and then send it?
Yeah. So what you're suggesting is called like scraping or proxying. Yeah. Yes. If you want, like, if your site A and you know that site B has this beautiful API that gives you the time, site A could literally on their server side, make that request, like you said, get the answer, and then provide it directly to their users from a site A URL, and then it would be allowed. Yes, that's correct. Yeah. So let's rule that approach out, because now their site is sort of proxying all this traffic. Say we want the user's browser to sort of directly make the request. In particular, like one reason why you might want to do that is because maybe this request gives you back different things if you're logged in as a different user or something like that. Now there's no way your server can do that, right? OK, so let me just move on, because it's a tricky one. So remember how we can make requests from images and styles and scripts to other origins? so what would happen if I did this? So site A wants to read data from a cooperating site B, and what if we initiate that request by putting it in a script tag? So scripts are not subject to the same origin policy, right? So that request can go out. And I mean, one problem is we can't read the data that comes back. Let me see, do I have the actual code? Yeah, this is what I'm talking about. So yeah, this is what I want to do. So site A says, I have a script from site B that's this API. And then that's going to get fetched, and this is going to be what's returned, and that's going to be evaluated as JavaScript. Is site A going to be able to do something with that to sort of read that out? Would that work? I mean, so first question, is this valid JavaScript syntax? It is? Why do you think it is? JSON, yeah. So JSON is a subset of JavaScript. So that you'd think it would be valid. It turns out it is a subset of JavaScript, but it has to be used in sort of a certain context. Like you could say var x equals this, and it would be valid. But this by itself, this actually gets treated as a sort of a scope brace. And then at some point, I think you get a syntax error somewhere here because you made a scope, and then you had a string, and then you sort of randomly had a colon, and then it's a syntax error. So we were able to make a GET request to this other origin. We were able to get the response back, and we were able to execute it as JavaScript until we hit a syntax error. So, but we're close. It feels kind of close. Like maybe we can do something with this. Read the error. That would be really gross. But honestly, not that unexpected for the web. Yeah, an idea?
It's a little weird, but could you put that script tag inside of another script tag and say like let variable x equal that script tag?
Oh, I see. To sort of try to augment the script. Yeah, I don't think there's a way to do that, but that's a good idea. Good thinking. But yeah, so the core problem here is that, I mean, basically we can't read what script is executing. All we can do is sort of execute the script and then observe the results, right? So first problem is it's not valid JavaScript, and second problem is we can't access the data at all. So there's this thing called JSON-P, which is a clever hack around this problem. So the idea is, what if we get the server to cooperate with us a little bit here? So what if we could tell the server when we make the request, hey, wrap the JSON in a function called whatever I want them to wrap it in. So I could tell them, hey, I got a function called handle time. So please, when you give me back the JSON, just kind of surround it with a little bit of that and a little bit of that. Yeah, and then the server, if it knows to do that, will helpfully cooperate and give you that response. And then you can implement a function called handle time right before you embed that script. And now you have this sort of communication going on. Super hacky, but it works. And this works because this is sort of valid JavaScript. You have to sort of know what the function name is going to be in order to sort of intercept it there. But we can tell it with the callback parameter. OK, so I think we're almost out of time. Let me just finish up with JSON-P. So basically, the downsides of this are from site A's perspective. So remember, site A is the one who is I think I might have flipped this. Sorry, yeah, this is from site B's perspective. The problem is that server now has to write additional code to support these requests across origins, and it has to sort of know to wrap its responses in this function call syntax. And it needs to be really careful, actually, because there's some JSON strings which are valid JSON, but which are not legal JavaScript. In particular, there's some white space issues. So it might actually produce invalid JavaScript files if it naively concatenates that together. And the other problem is, what if the user does control that callback name, right? So the user can what if the user gives like a malicious, what if they just give a bunch of JavaScript code or something? Now that code is all going to get included automatically into that response. That's called injection, and we're going to talk about that next time. I think next time. So there's an attack called the reflected file download attack that was which can be caused by not sort of sanitizing that callback argument. And then the problem from the other site's perspective is they were just trying to fetch a bit of data from another origin and do something with it. But in order to enable that, they literally had to include a script from that other site, which enables that site, say the server gets hacked, and that it starts returning completely different code that doesn't follow this format here. Now this site has sort of remote execution on this site here. So really, we wanted a way to just sort of ask for a bit of data, from this other site, and in order to do it, we had to give it full execution access to our whole site. It's kind of a bad idea. You want to limit that a little bit more than that. So that's pretty scary. So anyway, next time we will conclude with sort of a way to do that, and then we'll talk about the cross-site inclusion attack, which is really cool. Cool, thanks.